Okay, we are now up to, well, this is actually the second last one in this topic, but we're also up to the, damn it, it's close enough stage of maths, which, funnily enough, is actually very valid. Uh, if I were talking to you about how far we are from Sydney, you would not give me an answer of 325 kilometres or 323.482 kilometres. We don't need that sort of accuracy. Okay, you'd say about 350k or whatever it is. Okay, we don't need super perfect accuracy, um, and that goes with a lot of measurements. If I were measuring the classroom that we're sitting in because I wanted to work out carpet, more often than not, you're going to measure it. You'll probably measure it to millimeters, but when someone says, "Oh, was it 8 meters?" you go, "Yeah," or 8.5, or whatever. It's close enough. Um, you do need precise measurements sometimes, but a lot of the times near enough's good enough. And luckily, we've got a couple of ways of doing that. So the first one we're going to look at is what we call scientific notation. Um, so sometimes scientific notation is also known as standard form. Um, Now, for those of you that are going to be doing physics, you'll find that we have a very similar thing that we use in physics, and a lot of the time that's called engineering notation. And the only real difference is the power that we use. But it's all the same. It's just to make our life easier and make it much more convenient. So here we go. The land surface of the Earth is approximately 153,400,000 square kilometres. I guarantee all those zeros wouldn't be there if you measured it precisely. But that's an approximation, and we're going to now make that approximation much more convenient for ourselves. And when I say convenient, you might look at it when we're finished and go, hang on, that's not actually much more convenient. It's actually more complicated. It looks more complicated, but if you're using a lot of these numbers and you need to compare them quickly, this is a much easier way of doing things. All right, so let's do it. We've got 4 steps up here that we're going to look at. We're going to find the first 2 non-zero digits. We're going to put a decimal point between them. So that's a number between 1 and 10, because all of our standard form or scientific notation numbers will be between 1 and 9.9999999. Count the digits between the new and the old decimal point. This is the power of 10. Power of 10 is positive for large numbers and negative for small numbers. Yes, that's correct. We can go into the negatives with the power, and that just means that it is tiny. All right, let's have a look. So our number is 1534, blah, 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 blah. So let's just write down the non-zero digits. So 1534. We're going to put a decimal point between the first 2 of those digits. So the first ones are 1 and 5. I'm going to change colors to green. I'll put my decimal point there. So I've put that there. Then I need to count the digits between the new decimal point and the old decimal point. Now, when we say the old decimal point, we're going to look at this number here, 153,400,000. There could be a decimal point there and zeros all the way down. We don't write it like that because we're not stupid, but that's what they're talking about. They're talking about the decimal point would technically be there. So we're going to have a look and see how many spaces they are between this point. We've now put a decimal point and over here. So we've got 1, 2, 3, 4, 5, 6, 7, 8. So we've moved it 8 times. So our power is 8. So I'm going to write times 10 to the power of 8. And that is our final answer. So the number 153,400,000 also equals 1.534 times 10 to the power of 8. Now, in these numbers, you are always going to have a times 10 to the power of something, and we've just worked out how to do them. So that is standard form or scientific notation. And like I said, while it doesn't look more simple at the moment, it actually is. And if you ever have to work with multiples of them, it is so much easier. Yeah, we're done.